Welcome to Math 105, where we are working on those marble problems with our Excel sheets. We are under our permutations tab on our Excel book. So before we were talking about how to do the permutation and combination, and now we're just going to be working on the marble one specifically. This is just kind of additional stuff that you could add to your Excel sheet. Notice that this one isn't likely in your student books unless things have changed recently. I just copied a bunch of these just prompts that we were seeing in class. And then I just want to make them as generic as possible. Now we are just going to be working on entirely this example 4. So your totals won't change, but the word problem of itself will. So it says, how many sets of marbles are there possible? So first thing, our bag contains 3 red, 3 blue, 3 green, and 2 yellow marbles. So it says, how many marbles do we want in total? So we always want your total first. That is going to act as our N. So 3 plus 3 plus 3. And if you want, you could always do that here. You don't have to do anything in your head. 3 plus 3 plus 3, and then plus our 2 makes 11. Now, when it says set up, so let's see in this first one, when it says a set of 4 marbles are possible. So let's try our 4 to start. And then anywhere on here, when we want to figure out, okay, well, for these to be unordered, we don't care about the order in which we get them, other than I just want, of my bag of 11 marbles, I just want to select 4. So we're going to be working with combination. So we said, okay, how to do that? We said is comp in. Our number is 11, comma, 4 are being selected. So you get 330 marbles. Now the set of 4 or the set of a number is always what is going in your hand. So in hand. So at the very end of each problem, we want to make sure that in your hand, we actually have satisfied the 4. Now, some of them, we might have different alternatives, in which case we need to just be very strategic as to how many are being selected, how many are being discarded, and so forth. Now, we could always change this. Let's try the set of 3 marbles. Again, just working with a total of 11, I can change that to 3 and automatically have my answer. So that's why this kind of setup is a little nice. And so again, total, I'm just going to do 11 again if you want, again, because some of your homework problems, they don't all just kind of format like this. They'll have different totals, but you can set up just as we did here, just counting them up. Now this one, it says, how many sets of 4 are there such that one is a different color? And I think, let's see. Okay, so we have our 11 in total, and we want 4. And let's see, we have 1, 2, 3, 4. Yep, must be my other sheet that I know I have a problem on. So at the end of the day, we want 4 marbles to be in your hand. So in that time, though, I want to make sure I have a red, what else? A blue, a green, and a yellow. And I want 1 of each. Therefore, when I do my combination, I'm going to say, well, instead of doing the total in the setup here, I want to make sure that I'm pulling from my red. So I guess the total in the set doesn't matter as much for some of these. However, when we do come back and do your probability, that will come into play a lot. So perhaps a different setup is that you tell me how many red total there are. So maybe I do that setup instead. And you'll notice that as I'm going through, I am changing these a little bit. Let's see if I can move this. Insert. Let's insert a row. We'll do. So total red, we have 3. Total blue, we have 3. And again, 3 and 1. We're going to say equals combination of my 3 total red. It just says we want 1 of each different color. So comma 1. And again, equals, and actually, yeah, I'll do 1 more of my 3 that are blue. Notice I'm selecting up here. I want 1 blue. Now, what's nice is that what we can do is when we move this over, we can highlight and drag, and you'll notice that these numbers are popping up. These are still significant. Now, this is actually too yellow, and you notice that has changed. that is just signifying these ones. Of my 3 red, there's one way to choose, or sorry, there's 3 ways to just choose one. Of my 2 that are yellow here, there's 2 ways to select one of each. And again, blue, I'm getting these 3 right here, and then again. So notice that because I have entered in the selected up here and this one isn't going to change, I can in fact drag. Now, if there are other conditions, let's say it said 2 red and one of each color and maybe a set of 5, then I would want to make sure that I isolate the color first. So we could do that. And I could say, okay, of my total 3 red, I want 2 of that. And again, that number won't change because there's 2 ways to do it, in fact, right? But maybe if I change it over here. But I wouldn't want to drag this one. I would want to fix it up here first so that each of the color that follows is just a 1. So again, we'll kind of snap it back to what it originally was. Now, I'm not fully done. I need a total, which means that I get to sum all of these. Oh, that's what I did wrong. I need a total. Just losing my brain for a second. When we are selecting, right? In my first batch, I have only selected, one of my marbles. But again, I need 4 in my hand. So I was forced to go get a blue marble, of which again, I now have 1 in my hand. So now I have a total of 2, 1 red, 1 blue. I keep reaching back in. It's a forced action. So I get 1 more. So now I have 3. And then 1 more time. That forced action will have us multiply. So we're going to use the product of all of these numbers. So again, we have 54. You know, it looks like there is a slight mistake on my sheet over here. It's not 18 because I must have missed somehow the 2 that was here. So 3 times 3 is 9 times another 3 is 27 times 2 is that 54. I was curious as to why that's wrong. So it's sometimes nice to reflect why I did something in the past. I knew there was an error somewhere. I did not think that was where it was. All right, when it says how many sets are possible in which all blank color are selected. So we could say that, let's see, all red are selected. So we're on this one. So say all red. So of my total 11, I'm still selecting, now I'm selecting 3. And in my bag, there are 3. So if I want to grab all 3, I'm going to say equals combination of my 3. I want to select all 3. And there's only one way to select all 3, and that is my response. Now notice that if it was a set of 4, right, I chose all 3 red, right? Of my 3 red, I chose 3, but I need to get some more. So I would come back and I would not so much from my 11, I would take away the 3 that I had in my red color, right? Take that all out of my bag. So now I'm left with 8. Of my 8, I just need 1 more because I have the 3 red in my hand and I need 1 more. So we have 8, which makes a total of 8 different ways of that happening. Again, if I changed it, let's say a set of 5 of my remaining in my bag that are no longer red, I would then amp it up to 2. We always want to make sure that this second number in each, when we total them all up, they come out to our set of number. When it says how many sets are possible in which no blank color is selected. So let's take a look. So it'd be this one. No green are selected. So again, green. We have a total of 11. We said we're doing a set of 4, of which there are 3 green. Now we do not want green, non-green. So if we don't want to choose green, we're going to take them all out of the bag. So we're going to take our 11 and subtract out the 3 that are green. So now we have 8 non-green that are left in the bag. So now when we do our selection, right, now that we don't have our color constraint, right, green is all out, I just want the 8 that are left over. I'm going to select 4 at random. So we have 70 different ways in order to do that. And again, you can see that discard pile, right? We're taking out the 3 that are green, we're throwing them out of the bag, and then we're using the 8. Now, when there are all our alternatives, we're going to continuously use that that discard or the newly discarded pile. What I mean by that is if I look down here, when it says how many sets of blank are there in at least blank are selected and blank color, again, trying to get as general as possible. So over here, how many sets of 4? So a total of 11. How many sets of 4 are possible in which at least 2 are red? So of our red, there were 3. Now, from our alternatives, right, when it says at least 2, right, that means we could have 2 or more. So 2, 3, 4, 5, 6, and anything more than 2, right? But red we only have 3 of them. So we have either 2 red or we have 3 red. So in this category, we only have 2 that are red. It's a equals, actually, before I do that, I also want to do non-red colors. Now, the reason for us doing these non-red colors is that we will end up discarding. So when we do equals combination or combin, right, of my 3 that are red, in this scenario, I'm going to choose the 2. In this scenario, I just want 2 red. Now, because I'm not allowed any more red, I'm going to take the 3rd additional red color left in the bag, and I'm going to take it out. So in theory, right, I have the 2 red that are in my hand, and the 3rd red I don't want to draw, so I also take it out of the bag. So that simulates that I'm going to take of my total, I'm eliminating the 3. It gives me peace of mind that when I reach back into the pile, into the bag, that I don't draw the 3rd red. So I'm going to be using this non-red 8 on my next one, and then again on my next one. So we do combination. Now, of my 8 that are left in my bag, I have 2 that are red. However, I need 4 in my hand, meaning that I need to take 2 more. Now, because it was a forced action, my total is going to be the product between these 2. I need in hand. Now, because these are alternatives, we are going to add between them. When it's not forced, we get to add. When it is forced, we get to multiply. So again, we're going to repeat the experiment again. And instead of taking 2 red this time, we're going to take 3 red. So of my 3 that are red, I'm going to select 3 of them. And there's only one way to do that, right? It's to grab all 3. Now, I have 3 red in my hand, so I just need to get 1 more. So equals, and again, all 3 have now been eliminated from my bag. They're either in my hand or we discarded it. Right? In this case, they're all 3 in my hand, which means I now have 8 colors left by hand, in my bag. And you can see that right here. So combin of my 8. I now just need 1 more. And again, it is a forced action. So we get to multiply these 2. And we will be adding between these 2. So we have a sum of this. Well, actually, we'll just do some of this. So we have 92 different ways of this occurring. This again is our total. I don't love this setup, but it does kind of show you how you can use Excel and still completing your homework. All right, now let's talk about this last one. How many sets of 4 are possible? So again, total 11. 4 are possible in which none are red. So we have red, we have 3 of them. So let's go ahead and eliminate the red. None that are red. They tell us right off the bat, don't select any of the red. Now it says, but at least one is green. So let's go ahead and look at green. So of our pack, there are 3 that are green. And then again, we will be discarding just like the previous one. Anytime there is a color of interest, we'll also be discarding. I discarded my 3 red, and now I'm going to discard, my green. So again, of my 8 that are in the bag, I need to take out 3 of them. Now you can eliminate this part just by subtracting out 4 or subtracting out 6, the 3 that are red and the 3 that are green. And you'll notice here we've discarded them as well. So again, we need 4 in hand. So when it says at least one is green, right, that means we could have 1 green, 2 green, or 3 green. Say 1 green, 2 green, or 3 green. So of my 3 that are green, in this scenario, I'm only going to choose 1 of them. So 1 of them goes into my hand, and now I just need to get 3 more. In my bag, though, I've eliminated my 3 that are red. And now, for peace of mind, I'm going to also eliminate the remaining green in my bag. So I'm going to take out essentially all 3 green, leaving us with 5 non-red, non-green. So of my hand, non-red, non-green, and I need 1, 2, 3 extra colors of forced action. So we'll multiply. So we have our next scenario. We have 2 that are green. So again, so of the 3 green, I'm going to choose 2. And now of the remaining 5 non-red, non-green, this time I selected 2 and I need 4 in my hand. So I need 2 more. And again, it is a forced action, so we'll multiply. And one more time, this scenario of my 3 that are green, I needed to select 3. There's only one way to do that. Now of my 5 that remain in my bag, because again, I've now successfully have all 3 in my hand. So there's 5 left in the bag that are not red and not green. That would be the 3 blue and the 2 yellow. Let's see. And I needed 1 more because I have 3 in my hand. Again, forced action. We'll multiply. And because we are talking about alternatives, scenarios, options, we're going to go ahead and sum these 3. Now we can do the opposite, in fact. So instead of saying at least one is green, you could say in theory, right? We could pull none that are green and then go ahead and subtract those options out from our total being 330 different ways of just selecting 4 in your hand. We do that a lot more when it comes to the probability of these. You will see these marble problems again in chapter 7.4. So this is where we want to master these problems. And then in chapter 7.4, we just do the extra element of just finding the probability.